Hello everyone, welcome to my talk from developer to architect in the age of AI. I'm truly delighted to be here with you in the Build and Grow Women on Stage conference. My name is Racheli Ebner, and I'm the Distinguished Engineer and Intuit Israel Site Architect. I lead tech culture, innovation, and enterprise architecture for the Israel office. I've been in the software industry for over 25 years. My background includes 10 years as a software architect, over 20 years in system architect roles, working on everything from small projects to enterprise-wide architectures. My academic foundation is in physics and computer science, and over my career, I've been fortunate to be the co-author of 22 patents. More recently, I founded WIP, Work in Progress, a venture through which I conduct workshops and provide one-on-one mentoring to empower women in technical roles. I work for Intuit. Intuit is a fintech company that created a financial management platform for both households and small businesses, reaching 100 million customers, largely in the US. It all started in 1983, when Scott Cook, the founder of Intuit, saw his wife sorting through piles of receipts in a shoebox and said to himself, "There has to be a better way to manage household finances." Today, 40 plus years later, Intuit continues to improve the lives of millions. With branches in 9 countries and a team of 18,000 employees, the company serves users in more than 180 countries. Intuit's development center in Israel is the company's second largest outside of the US, and it is considered a global leader in innovation in the fields of fintech, trust, and data. The center in Israel has grown significantly in the recent years and currently employs over 500 people, and the vast majority of them are technological professions. A while back, a few years ago, I gave a talk about what skill sets are needed to become an architect. And I gave a list of 5 of these skills that are needed for a software engineer to become a good architect. And this is what I mentioned. I said, first of all, we need to be technologists with the ability to write code, understand technology systems, and actually even like it, if not love it. Secondly, one needs to be a systems thinker, capable of understanding large systems, their interdependencies, and more importantly, have a vision how to evolve a system, a complete system, from its current state to its target state. A third quality we want to be are organizers. We need the ability to bring order, standards, and good integration practices to software development and software projects. Being a good communicator, skilled in ensuring a shared understanding in meetings. We want to be able to use diagrams and manage technical discussions effectively. It depends on us. Having the ability to be a simplifier and bring simplicity to complex systems is the final important skill set that we want to have as an architect. But does that still hold? The entire world is now shifting with the emerging of new AI technologies. It's not only generative text capabilities. We are seeing image generation, video generation, and AI is now also present in the physical world with the automated cars, robotics, and manufacturing. We also see technology costs are dropping rapidly. Cost per 1 million tokens dropped in orders of magnitudes, and the quality of the output made huge jumps. Platforms are evolving. We are seeing new AI platforms that are meant for development, and we will talk about them very soon. And we also see a massive business disruption. Every business sector is now looking into how to use AI to automate, decrease costs, increase speed. It's law firms, it's medical, it's everywhere around us. And we have to ask ourselves, what does it mean for us as software developers and as architects? So I want to look into a few directions where we can look at AI-enabled tools that influence our day-to-day work. And I will look a little bit at code assistance and application generation, a little bit into DevOps and SRE, enablement by AI. We'll look a little bit into AI platforms and also talk about AI native architecture. So first of all, let's look at coding assistants that integrate with your IDE. They can provide smart coding suggestions, they can generate tests, and even write complete code snippets. They can also answer questions about your code base. Have you tried any of these tools? I highly recommend it. Not only code assistants, but there is also a new set of AI tools that are not just trying to help us with our current coding work, but aim to generate complete applications end-to-end and complete coding flows from scratch. You provide a description of the code that you want to be generated. You provide a functionality that what you want to be the outcome, and the tool generates it for you. In some cases, it even includes backend database schema, pipeline, and deployment. I tried some of these tools, and it introduced new ways of working on code and technology. We still need to understand what it means for us as developers. Will we write less code? Very likely. Will we be in charge of delivering end-to-end features and capabilities to improve the products that we are developing? Absolutely. So let's look at a quick example. Lovable is one of the tools that I've tried, and it is integrating your code in GitHub, Supabase as a backend as a service platform, and generates a UI using React. And you couldn't provide prompts to it that say something like create a to-do application, or after the simple application has been created, add user authentication. Only authenticated users should be able to use the to-do list, and when a user is not authenticated, the login form should be shown. If a user is authenticated, there should be a logout button. And this is a screenshot of a very basic to-do application that has been generated by Lovable with the ability to be deployed, including backend, including database tables. So that's a rapid development speed increase. Let's look a little bit at the impact of AI into DevOps and SRE world. Here are just a few examples of what is possible. In the CI/CD domain, we can see automated pipelines are using AI for build optimizations, and we could also see predictive test selections that accelerate feedback loops. In the log analysis domain, we see AI identifying log anomalies and providing real-time detection of operational issues. In the security domain, we see AI assisting in threat detection, scanning the code, and even providing automatic remediation of common vulnerabilities. And finally, in incident management, we see trends of predictive failure analysis to minimize downtime, and we also see AI assisting in incident response, helping developers find all the information they need and even suggest how to fix the current issues. We have mentioned the appearance of complete AI platforms. They are provided by the large vendors, and they aim to bring a large set of tools for developers and help a wider audience learn and use AI models in their applications. So I want to go beyond what we spoke about until now and ask some difficult questions. First of all, what time frame are we talking about? Everything I described to you until now is practically happening today and may still impact us in the next 1 or 2 years. But what happens if we look 5 years ahead or even 10 years ahead? Will we still have developer and architect as the roles that we're talking about? To answer some of these questions, or maybe even just give a feeling where we're going, I want to look at the question, what comes after software as a service? What would an AI native world look like? And for that, I want to go a little bit back in time. If we look at the last major transition in architecture, we need to look 20 or 15 years back to the transition from on-prem to cloud-native applications and architecture. The shift from on-prem to SaaS development was a fundamental change in how we built, deployed, and delivered software. It was a move from managing physical infrastructure to leveraging cloud platforms, and it resulted in faster development life cycles, in better scalability, and in a lower operational overhead. So what did the transition from on-prem to SaaS looked like? First of all, it was a transition from ownership of hardware and software to a subscription model, where users only pay for what they need. Secondly, it was a transition from manual to automated, where deployments and updates in the on-prem world were largely manual operations, and in the cloud world, in the SaaS world, we're looking at automated continuous integration, automated deployment and delivery. And we also saw the transition from monolithic software to microservices, where in the traditional on-prem software, things were monolithic, and the SaaS encouraged the microservices architecture to increase the flexibility and resilience of the software we developed. In the cloud-native applications are designed to take full advantage of cloud computing's distributed architecture. And we came to use microservices, run them in containers, have the containers orchestrated. We developed a DevOps culture, and we use API-driven and event-driven communication methods. We also saw new roles evolving, like cloud architects, DevOps engineers, site reliability engineers, Kubernetes administrators, cloud security engineers, platform engineers, and more. So when we look at that transition, maybe we can borrow a little bit of that and try and look into the future and ask ourselves, what would an AI native application look like? An application that is not a classical cloud application where we want to integrate a few AI features and capabilities, but an application that is designed from the ground up with AI in mind. What would that look like? So I want to offer a few possibilities and directions. No one really knows where it's going to go, but here are some thoughts. So first of all, we're going to see something that's called an AI fabric. It's beyond the cloud infrastructure. Today, cloud infrastructure is providing compute, storage, and networking, and cloud native leverages this for scalability and resilience. What we're going to see is probably the emergence of an AI fabric, a layer of infrastructure that is optimized for AI workload, which will include specialized hardware like GPUs as a commodity. We're going to see distributed AI training and inference platforms that are accessible as services. We're going to see real-time data pipelines designed for AI model consumption, and probably model repositories and versioning systems that are integrated into the infrastructure. This fabric will abstract away the complexities of AI infrastructure and make it easy to consume the same way that cloud services are easy to consume today. A second trend that we might see is the semantic understanding as a core paradigm. In cloud native, we focus on data structures and API-driven integration, event-driven integration, but the level that we have is the level of data. In an AI native world, software will shift from processing data to understanding the meaning. And therefore, we can probably see things like semantic search, knowledge graphs that will be used everywhere. We will see natural language interfaces instead of the traditional UI interfaces. And we will see applications that will reason, infer, and generate content based on the context that they are provided. We will see a transition from data as the primary storage type to knowledge and to understanding. And this will lead to much more intuitive, personalized, and context-aware applications. And finally, we will see autonomous agents and the decentralization of software logic even beyond what we have today. Cloud-native applications today rely on centralized cloud services and microservices. But we could predict that in an AI-native future, autonomous agents will become core components of the software architectures. Agents will perform tasks, learn and adapt without explicit programming, and decentralized AI models and federated learning will enable distributed intelligence. Software will be composed of these interacting agents that will create dynamic and adaptive systems. And this will enable the development of highly complex and adaptable systems capable of handling dynamic environment. So looking ahead on the transition from cloud-native applications and architectures to AI-native application and architecture, we could imagine a few of the following trends. A move from a reactive to proactive approach. Software as a service is often reacting to user input and AI native applications can anticipate need and automate tasks autonomously. We could see a transition from data processing to intelligent reasoning, beyond simple data storage and retrieval, to leveraging AI for insights and decision-making. We're going to see a move from feature-based to context-aware, shifting from static features to dynamic, personalized experience based on user context, even more than what we have today. We'll see a shift from human-driven to AI-augmented, integrating AI deeply into every workflow to automate complex processes and enhance human capabilities. From cloud-centric to edge-aware, meaning that distributing AI processing across cloud and edge devices for real-time responsiveness, meaning that AI, like today, might run on our phones and not just centrally on the cloud. And from general purpose to specialized intelligence, creating applications that have deep domain-specific knowledge and the ability to learn within their domain. So all these trends are just speculations and predictions, and we don't know exactly how things will evolve. But with those very fundamental shifts, we could also imagine new roles and new types of professions getting born. So a little bit similar to the transition we saw from on-prem to cloud, engineers didn't disappear. They simply got specialized, they got new names, and they got new responsibilities. But we are still engineers at heart, working on technology, delivering features to delight our customers and help our fellow developers. And finally, we all need to overcome our FOMO, the fear of missing out. There are lots of new AI tools that are coming out constantly, and we have to focus on understanding what are the important ideas and simply not be afraid to start and try new tools. Yes, we will miss out on a lot, but everything new that we learn is our gain and will take us one step forward. So I want to share with you finally last advice, where to start, and the answer is simply jump in. Jump where you are, in what you do, and try to incorporate as much AI tools as possible to learn them. So for instance, the AI tools that I use to prepare this talk are ChatGPT as well as Gemini for research and brainstorming. I used Gamma to create a first version of this presentation. I used NotebookLM to create notes and to create some scripts for my lecture. And finally, I wanted to use Astria to create a headshot, an AI-generated headshot for myself, but eventually it didn't happen. So, going back to the first slide that we talked about, what is the architect skill set that is needed in an AI era? And I want to argue that the same skill sets are still needed. We all have to be good technologists that understand core AI principles, models, data pipelines, and deployment infrastructures. We have to be system thinkers and understand how AI components integrate into larger systems. We have to strategize how the AI role in the future system vision, and we have to consider the ethical implications. We have to be good organizers and establish standards in how our projects work, both in using AI and ML models, in data management and integrations. We have to be good communicators. Because of the complexity, things are going to be more difficult to understand, and we have to help meetings as well as documents be as clear as possible. And we have to be simplifiers. Complexity is increasing, and it's up to us to keep everything as simple as possible, but not too simple. So, these were my thoughts and musings about where we're going with AI and what an AI native architecture might look like and how it might influence our roles as software developers and architects in the future. Thank you for listening and for being with me. See you next time.